welcome to yet another session on IoT security. We have our trainer come technical evangelist, Mr. Shafi Patel, who will be conducting this session. Uh, I hope you will enjoy this session, take notes, and you all must be aware we are part of the Collabora family. It's a 3-decade-old organization. We have presence across 45 countries, courses, 450 plus courses at your disposal, and these are all done with a pool of about 7,000 trainers that we have. Then in this tough time, one good thing has happened that there's suddenly been a huge surge in our online training. And that's the reason Cognitia is taking pride in hosting as much as technical sessions, which basically clears a lot of doubts, guides the participants to choose the best course for their career. So with all this, I am handing over the session to Mr. Shafi Patel. He will lead the session from here. Should you have any questions, concerns, please park your questions. We will answer that one by one at the end of the webinar. And feel free to reach out to us should you want to enroll yourself for the sessions. Thank you so much. Safisha, you can start the session.
Thank you, Vishal, and thank you for support team for bringing this webinar live. Hi, Kuar. Good evening. I can see a couple of familiar names here on my screen. So those who are joining today's session, I welcome you once again on behalf of Cognitia. Okay, so once again, I welcome you all to this webinar on IoT security and penetration testing. As we all know, this is an advanced topic, what we are gonna discuss today. So this may require a little bit of knowledge of IoT. In case if you have any doubts or questions, in case if you don't know the basic things, what you can do, you can drop your questions, and I will try my best to answer all those questions at the end of session during the question answer round, or I can reach out to you, or support team can reach out to you with the answers post webinar. So let's get started. An introduction to IoT. As we all know, IoT is one of the most fascinating technology of today's era, one of the most promising. And looking at the trends now, it has been anticipated that IoT devices, which were earlier figured out to be 50 billion by 2020, now they are going to be more than 500 billion by 2030. So we will have more than 500 billion connected devices by 2030. You can imagine the scale. IoT, as defined, is the extension of sensing, computing, communication, and actuation to mundane objects, along with a new class of advanced software applications with augmented cognitive capabilities deployed on them to transform these mundane objects into intelligent objects. These intelligent objects are expected to generate physical actions, to manipulate a real life environment, and most of times we expect these physical objects, these smart objects, to make decisions on their own without any human consent. One of the best example of a smart and autonomous IoT system is a driverless car. We all know lots of research is going on in this area, and once this driverless cars are going to be there on roads, these cars are going to be running on their own. The systems deployed on these cars are going to make their own decisions, and this concept or idea can be extended to millions and billions other objects. For example, a simple vacuum cleaner in your home, or your door. A system deployed on your door can recognize your face, and it will welcome you once you reach home. So this is the world being promised by IoT. Now we all know, and we have been learning this for years. Personally, I have been teaching how to architect, how to design, how to build, how to deploy IoT solutions for the last 3.5 years. I have total 22 years of experience. I I got into this area 3.5 years ago, and since then I've been teaching IoT. So based on my experience in my class, I always highlight these 5 key considerations to build a perfect IoT solution. See, our IoT solution, especially the software components or software applications, are hosted on resource constrained computers available to us in the form of IoT devices, high end gateway solutions, cloud platforms, and on prem IT infrastructure. Now, we need to ensure reliability, resiliency, interoperability, and most critical, security and privacy of the technology infrastructure hosting our IoT software applications. See, it all depends on how good your technology infrastructure is. And this is the reason while building or architecting an IoT solutions, this five minimum you will have to at least take this 5 key parameters into consideration. There could be more based on your project's requirement, but these 5 are applicable to all the types of IoT projects. Now see, today's session is to dive deeper into those 2 primary key considerations, and which are those security and privacy. See, it's highly complex. It's a complex endeavor to address these 2 greatest concerns of technology users, those who are buying technology solutions, those who are adopting technology solutions, individual users, businesses, and organizations. They are striving hard to find out solutions to take care of security and privacy of their asset. Now see, IoT doesn't only provide access to cyber asset in an organization. IoT also provide access to physical assets. So an electronic lock placed on your door, once compromised, can allow anyone to get into, right? A production system running on a factory floor, once one of the device controlling it is compromised, the entire operation of the factory is compromised, right? So addressing IoT security and privacy are most critical. The reason behind that is complexity of IoT solutions. We all know an IoT solution is an ensemble of devices which are equipped with sensors to acquire data, network, local area network, as well as internet, the global communication infrastructure to transport data, cloud platforms offering storage and data analysis as services to IoT devices, end user applications running on users' mobile phone or tablets or any other handheld device, for example, even on a wristwatch. And similarly, third-party integration tools and enterprise IT solutions. This all, when it comes to addressing security of your IoT solutions, you need to address it holistically. You need to address the security of all the components, not just securing one of those. See, most of times when it comes to security, people only care for the data security, and that too when your data is on the fly, when your data is on the network. So most of times when we talk about security, we only talk about network security, but IoT, in case of IoT, you need to think more. You need to take all the components of your system into consideration. Now let us look at this why. So as I just explained, and this picture will depict it more clearly. In an IoT solution, data flows from end to end. And data, as we all know, is one of the most precious asset for organizations, for individuals, and for businesses. So this is the reason why most of the existing tools, practices, and principles which are employed by cybersecurity professionals information security professionals and computer security professionals are equally applicable and are now being borrowed in IoT security domain too. So one of such existing principle of information security called the classic pillars of information security. Confidentiality means keeping sensitive information secret and protected from disclosure. Integrity, ensuring that information is not modified accidentally or purposefully without being detected. And availability, ensuring that information is always available to its owners, authorized parties when needed. These three terms combinedly called CIA triad, or also called AIC triad, is equally applicable to IoT security, especially when it comes to address communication security. Okay, so I'm just going to give you a practical example of how to address confidentiality. See, one of the technique, which is an ancient technique and which has been there in practice for years, is cryptography. I'm repeating it. The technique is called cryptography. Cryptography means making a plain text, converting either a plain text into something that is not in useful form. I'm just going to give you an example of one of the type of cryptography called symmetric cryptography. See, in cryptography, we use algorithm and keys. Algorithms are used to convert plain text into ciphertext. Plain text means simple message, and ciphertext means encrypted message. And keys, this process depends on key. So if you change the key, the generated ciphertext is going to be different. Okay, so I'm just going to show you a simple example based on one of the library from Python. The library's name is cryptography, and one of the algorithm that has been imported from this library is Fernet. So in the first line, this is to import Fernet algorithm. In the next step, we are generating a key. Just for your info, let me do one thing. I will print this key on my screen so that you get an idea. How does a key look like? A key is nothing but a fixed length alphanumeric code. Okay, so here the key is being generated. I'm going to print this for your information. And then in the next step, we are going to generate a cipher. A cipher means a tool, an object which is going to be used to call encrypt and decrypt methods from this library or from this module Fernet. Okay, so here the key is being generated. Here the cipher has been generated. The object has been generated. In the next step, I'm converting this message, a simple text message, into ciphertext. I'm going to print this encrypted message for you. And then I'm going to use the same object cipher to decrypt the message. Okay. And I'm going to print decrypted message for you. So you will have an idea how does encryption, decryption takes place. So as you can see here, this is my key which has been generated by Fernet algorithm. I have used this key to convert plain text into ciphertext. So this is my encrypted message, ciphertext. I can share this message with anyone. And as you know, even if this message is intercepted, if this message is captured while it is being communicated, it is of no use for the receiver. So any unauthorized person who doesn't have key will not be able to use, will not be able to understand this message. Only the only person who can decrypt this message, who can convert it back into normal message, is the one who has this key. Okay, so this is an example of symmetric encryption where sender and receiver both use same keys for encryption and decryption. See, a detailed discussion on cryptography and its other primitives is out of scope of uh, this discussion because it's a short duration webinar. So I'll just make it quick to share more and more examples with you. To learn all these things in detail, you can join our training programs. We are launching a new batch to teach security and penetration testing applied to IoT from 16th of this month. Okay, so this was an example of symmetric key cryptography. Now I'm going to share an example of asymmetric key cryptography. To know more about this example, I've taken from this website. So to learn more about, you can visit here and refer to this blog. See, this is an example where two separate keys are being used. So asymmetric cryptography, it uses two separate keys, a public key for encryption and a private key for decryption. A public key of receiver, whoever is on the receiving side. So let's say that there are two users, Bob and Alice. Let's say Bob is your IoT device, Alice is your cloud platform. So the cloud platform's public key, because IoT device is supposed to send data to cloud platforms. The cloud platform's public key is going to be available in public domain. Means if there are thousands of IoT devices, all of these IoT devices can use public key of cloud platform to send data, post encrypting it using public key of cloud platform. Now, how is this message, once it is received by cloud platform and a software application running on cloud platform, is going to be decrypted? So just for your information, a message encrypted by public key of a receiver can only and only be decrypted by private key of receiver. And receiver, in our example, receiver is cloud platform. receiver is Receiver never shares this private key, and this is why we call it private key, with anyone. Okay, only public key is going to be available in public domain. Private key is only going to be available to owner of the private key, in our case cloud platform. See, this public key and private keys are mathematically related, but you don't think that if public key is known, it can be used to generate private key. Yes, there is a mathematical relation, but private key can't be generated using public key. So keeping the public key in public domain to allow anyone to send data in a secure way is not an harm. Okay, so here in this example, I'm giving you an idea how this private key. So here a private key is being generated, 2048-bit private key, and from this private key, public key is being generated. Okay, so in this line, public key is being generated. Both are converted into a standard format called PEM and then saved locally, private key.pem and public key.pem. And then here, you know, both the both the keys have been read and are converted into um, serial strings, you can say, private key and public key. Now see here, public key is being used to encrypt a simple message, hello, this is my secret message. So here, public key is being used to encrypt the message, and then encrypted message is going to be printed just for your information. And then finally, here I'm using private key to decrypt the message and printing it back. So this is an example of asymmetric cryptography where, so look at this. This is encrypted message and this is your original message. So the difference between symmetric and asymmetric cryptography is application of keys. Symmetric cryptography uses a common key, whereas asymmetric cryptography uses two different keys, public and private. There is a protocol called TLS. I don't know how many of you are aware of this, but those who are from those who use online banking, do you look at your browser and do you look at this lock icon? If you do, then do one thing. Next time you click on it and then you get into details, check whether connection is secure or not, and then who is guaranteeing this security, and then you can get more information about, this security measures. So as you can see here, most of times your lock, that lock is the indication of application of a protocol called TLS, Transport Layer Security. The currently in use versions are 1.2 and 1.3. Okay, so TLS is a cyber suite. It is not just one algorithm, it's a combination of algorithms. TLS employs both symmetric as well as asymmetric cryptography. Now, we don't have time to get into those details. Just for your information, I'm giving an idea. TLS, transport layer security, employs or uses both asymmetric as well as symmetric key cryptography. There's one more thing that TLS uses, and most of the websites and software applications which engage in communication on internet employs and for integrity check, and this method is called hashing. Hashing is a one-way encryption, and if you just go to Google and search for hash generator, you can find simple online hash generators. Okay, so I'm just gonna give you a simple example of generating a hash of a simple text. For example, my name. I'm generating a hash for this. Okay, and look at the length of hash. Okay, if I try to find out the length, okay, I can take this hash to Python, a Python shell, and I think here we can use a simple function alien to calculate length, right? It's a tricky way of calculating length, right? So see, it says 32 characters. So my name has been converted into 32 character unique hash code. See, hash codes are unique. Okay. Now let's say if I put a text of no matter how many characters. Okay. See, I'm putting characters which are certainly more than 32. Okay, even if I put 1 million characters here, even I put 1 million character here, the code is going to be a unique hash length. Let me show it to you once again. Length is going to be same. Okay, length is going to be same. See, 32 characters, right? So doesn't matter whether you put one character here or you put 1 million character or 1 billion character. It doesn't depend on length of your message. The hash generated is always of fixed length, and this technique hashing is used for integrity check. You know why? Because let's say, see, I typed my name and now I'm typing my name again, but this time I'm using See, I'm making some changes here. See, I'm putting my name, but now T is an uppercase letter, P is not an uppercase letter in my surname. See, I'm generating a hash for this, and look at this. Is this hash different from the previous hash? Let us go to Python shell and find this out. See, yes, so look at this. Length is same, but code is different. So this is how hashing is used. One of the application of hashing is integrity check of the information being exchanged, being communicated. And the second application of hashing is storing passwords on computers, on cloud platforms, and on devices, IoT devices, in a secure encrypted way. Okay, so passwords once converted into hashes cannot be converted back into normal text passwords, right? So the hashing is the technique used for password storage. So this is quite interesting. When you get into details of all these things, you'll find this area, especially cryptography, uh, offers you a lot to ensure security of your assets. Now, see, when it comes to IoT, we just don't think about confidentiality, integrity, and availability, but we also need to address resiliency and safety of our systems. Resiliency means your system's ability to bounce back to normal or near normal condition in case of any disturbance or failure. And safety means the system should not cause any harm, hurt, or injury to its users, as well as users should not become a reason of systems safety, right? So we need to extend this CIA triad when it comes to IoT. Yes, CIA is equally applicable, but you also need to take resiliency and safety as two key parameters along with CIA triad into consideration. Now see, working in IoT requires you to be familiar with key terminologies. Now here I will take only 1 minute of time to give you an introduction to these key terminologies and a relationship between them. So compromise, let's start off from bottom. Compromise means a system has been compromised, an asset has been compromised, right? An asset or system has unauthorized access. And what was the reason? It happened because of an attack. Okay, and how did this attack execute? The attack was executed by exploiting a weakness or vulnerability of the system. And what is threat? Threat is defined as the exploit potential of the vulnerability, and the person who takes advantage of this exploit potential is called threat actor. Okay, so what does threat actor do? Threat actor means a hacker or an adversary, a bad guy, who wants to get benefited from your loss. So this threat actor will keep an eye on your assets, will keep an eye on your uh, uh, systems, and once finds a vulnerability or the potential to exploit that vulnerability, it's going to execute an attack to compromise your asset or system. Now see, in this case, what do we need to do? See how critical this attacks are. I'm going to share two of such examples with you, two incidences with you. One instance took place in 2016, October 2016. DDoS attack, distributed denial of service attack, DDoS attack was executed. The target was domain name system provider DYN, an international organization. The compromise of their domain name system DNS servers brought down thousands of websites in Europe and North America, the uh, all the organizations, all those big names, their websites were down. And one thing that you need to notice from here is that in this attack, IoT devices were used as launch pads. Devices like printers, IP cameras, residential gateways, and baby monitors. And the bot which was used was Mirai bot. So this is a large scale attack which was carried out using IoT devices as launch pad. It happened in 2016, and now I'm going to share one incident with you which took place last month. Honda's global operations hit by cyber attack. Okay, and here, this attack was a type of ransomware. It was a type of ransomware. In ransomware, what do hackers do? They hack your systems, they shut it down, or they encrypt all the available data, and then they ask for money, they demand money. Once you pay them, then only they share the keys to decrypt your data or to unlock your systems.